you're going to do with your investigation, there are going to be 6 different quadrilaterals that you're eventually going to look at. I'm going to actually start with the parallelogram. I'm going to go a little bit out of the order that they've put them on there. So we're going to go through this first one together to make sure you understand what I'd be looking for and kind of some of the things we'll check. Okay? So name of the quadrilateral there at the top. We're going to do the parallelogram. Go ahead and write that in. And to make your picture bigger, you can enlarge and make it full screen down here. Make it a little bit easier to work with. Then it asks you to make a sketch of the quadrilateral you investigated. So start out with this sketch right here. So you'll have all the pieces in the correct spot. Notice they've drawn in the 2 diagonals, and they labeled where they intersected with E. So make sure you include that in there as well. Now, in order to have everything in one place, you sketch that quadrilateral, or in this case, the parallelogram. Next to it, I want you to transfer over the definition that you came up with the other day. Okay, so you should have a definition for parallelogram on there. So go ahead and write that next to your sketch. If you did not find the definition, then that's something you'll need to do. Let's find the definition right in now. Probably the best definition for a parallelogram would have something on there about the fact that you have 2 pairs of parallel sides. That's really the definition. The quadrilateral has 2 pairs of parallel sides. All right, from there we're going to try to answer these questions. Now, answering the questions, we're going to have to kind of think about our picture to help us out in some of the cases. The first one, though, wants to know, are there any sides that are parallel? And if so, which pairs? Well, we already know that there's some that are parallel. Their definition tells us that. But if I wanted to test to make sure which ones are parallel, well, we've already done enough with parallelograms to know that, like, AB should be parallel to CD. But one way I can maybe check it is if they're really parallel, then that means this angle right here should be supplementary with that angle right there. They'd be same side anterior. And notice you have all these measurements here that can help us out. So if I thought about this big angle where angle A is, they labeled it as DAB. And they said DAB was 133.01. If I thought about this angle down here, I have AEC. They labeled it CBA. They said it's 46.99. Well, if I add those 2 together, I get the 180 I expected. Okay? So for the parallelogram, we already knew that was true, so we didn't necessarily have to check that. But others, it may be harder to see if they're parallel or not. That might be something to check. So answering that first question, are there any sides that are parallel? Well, yeah, there are. I just listed one pair, AB and CD. What's the other pair?
AB.
Yeah.
DA.
Right. Okay, so you want to list both of those pairs. All right, the second question wants to know, are any of the sides perpendicular? So if they're perpendicular, we know they should form 90-degree angles. Well, did any of the polygon angles end up being 90 degrees in my picture? No. Okay. Could I have made them 90 degrees? Is it possible that, and if you grab a corner here, you're able to move your picture around? Notice when you move it around, it changes all the values. Is it ever possible for me to get to 90 degrees? You think I could rearrange it to make it 90 degrees anywhere? Let's see. And you can try it on yours as well. Getting closer. If you look at that, that's pretty close to all of them being 90 if I round them to the nearest whole number. So does that mean I need to change my answer to yes? No. Because remember, if it's going to really be true, it has to be true for all of the pictures. And I could only really come up with one picture there. So are there any sides that are perpendicular? In this case, no, there are not. Sides that are congruent. Well, again, we're pretty familiar with parallelograms. We know the opposite sides are the same, but I could always check by looking at the side lengths over here. And I notice AB has the same length as CD. I notice BC has the same length as BA. So I'd list those sides. Are there any angles congruent? Now, by angles, they're talking about the full angle here in the original figure, not the small angles that are around that figure. So we're talking about the full angle here that we have. Well, we do have two angles that are the same here. We have DAB and we have BCD. They're the same. We've got ABC, we got CDA that are the same. Okay, so when they ask about the angles being equal, they're talking about the polygon angles, not some of those other angles. Are the angles supplementary? Again, we're sticking to these polygon angles. Well, we already decided a couple were. We said these two were, these two also are. Any two that would add up to 180 would be supplementary. So we have some pairs there that are supplementary. The next one wants to know, are the diagonals congruent? Well, notice here it has the diagonal lengths listed. So you can just look at the diagonal lengths and see if they're the same or not. In this case, they weren't. One was longer than the other. The next one says, do the diagonals bisect each other? What's bisecting? They cross each other. They do make two pieces. They're only going to cross once. They make two pieces. What do you think is true about the two pieces? They're congruent, right. So what they want to know is, when these two diagonals cross each other, do they make two equal pieces here and two equal pieces here? Or in other words, they want to know, is AE the same length as EC? Well, notice all those little pieces are right here. And that's where you'll find that information. AE is the same as CE, so that one got cut in half. DE and BE are the same. Those got cut in half. So the answer to that is yes, the diagonals do bisect each other. If you have a situation where these two are the same but these two are not, we would say they don't bisect each other because only one of them got cut in half. 8 wants to know, do the diagonals bisect the opposite angles? So what they mean by that is, if I start here at D and I draw it to B, does it cut those two angles in half? That's where this information comes from here, where it says partial corner angles. So what I want to know basically is, do these two angles end up the same and these two angles end up the same? Or these two angles and these two angles? Well, let's check it out. If I looked at ADE, that was right here. It was 22.42. If I look at the side right now, or the angle right next to it, CDE, that's 20.42. So I got two different values there. So right away I can say no, they didn't bisect each other. And lastly, are the diagonals perpendicular? So where they meet here in the middle, do they form 90-degree angles? That information is going to come from right here. If all these are 90, then I would say they are perpendicular. If they weren't, so I'll say no. Yeah. All right, so obviously there's a lot of information that you have to check on these, so it's going to take a little bit of time. You're going to do that for all the figures that are listed here. So we've knocked out the parallelogram. You're going to now do it for the remaining 5 that are listed on there, okay? Each time, make sure you make the sketch. First of all, make sure you label the figure you're working with. But make the sketch and write down your definition that you came up with the other day for each one. These results they're important because we're going to have to tie them all together eventually.